I think it's kind of setting myself out from the other builders and competitors of building higher performance homes. Homeowners are getting more educated on the type of product they want and obviously to have better energy savings. Our key goals with this project was working with an energy advisor, having a mechanical designer involved to make sure the house was going to be comfortable, not have rooms that are going to be too hot or too cold in certain climates and seasons throughout the year. Overall, just having a comfortable home for the homeowners, and especially trying to save some money through having an airtight home and having a good system that actually is sized properly.
Once the decision was made to build to Step 4 of the BC Energy Step Code, I modeled the design in HOT 2000 to determine the effective R values of the building envelope to meet Step 4 metrics. I also coordinated with the HVAC designer and the builder to determine the overall HVAC strategy to achieve the required mechanical performance.
We were involved in the project before building permit stage to review the step code requirements, the energy compliance requirements, and how that affects the mechanical system. We had a design charrette. In other words, we got together over a Zoom call and basically discussed, looked at the plans and discussed what the homeowners' expectations were for comfort. We talked a bit about the budget. We talked about the energy performance targets. In this case, went from Step 3 to Step 4. The tools we used to manage that collaboration with the design team on our end was doing load calculations using the CSA F28012, which is the compliant methodology for doing load calculations. In addition to that was, our experience doing mechanical designs. Almost always we have situations where there are different levels in the room, unless it's a rancher. But even then, you have different exposures. For example, east versus west, south versus north, where the loads within the same space on the same level can vary substantially. When the loads are that out of balance, that is an opportunity to seriously consider zoning. There's also usage. For example, bedrooms, different than living areas, rec rooms, and so forth, kitchens. In this house, it was very advantageous to split the house into two zones. Most homeowners tend to want their bedrooms at a different temperature. We were able to retain the aesthetic in this particular house. First of all, as I mentioned before, with coordination, that's key. Duct sealing is pretty critical. If the system's not sealed, what you end up with is air loss along the way. Wherever the air pressure can breach the walls of the ducting system, and that'll happen, it usually happens closer to the furnace. So by the time you get to the further extremities of the building, you've lost a significant amount of the air that you intended to deliver there. So it's really, really, really critical that every cubic foot of air that you started out with ends up where you designed it to go, to deliver the comfort that is inherent in the design.
Since these homeowners moved in, they've been really comfortable. Don't feel any drafts, don't feel any cold spots. The house, they told me, it's really well heated and from room to room on each floor. So there wasn't much differential from the upper floor bedroom from one end to the other house. It was really well balanced, and they find that really comfortable in the house. And also the air quality is really fresh. There's not much dust. It's a very clean design.
Homeowners are very happy. Basically, it's mission accomplished, not by myself, but by myself as a team. In the end, we benefited greatly from the integrated design process.